MC4 solar connectors often get bad press linked to scenes like this. So my question for you is it the connector or the skill of the person making off the connector that is at fault? Poor quality connections in solar installations are a major cause of fires, so it's important for anyone installing solar PV systems to understand the critical role these connectors play. In this video, we'll try to unravel some of the myths and explore the reasons behind the fires and failures. What makes MC4 connectors problematic? These connectors operate in harsh conditions, handling high DC voltages and currents while enduring extreme temperatures, UV exposure, dust, rain and snow. We expect them to last for the lifespan of a solar module installation, often exceeding 20 years. However, issues such as high contact resistance, moisture ingress or mechanical failure can result in high energy arcs, posing a fire hazard, especially if flammable materials accumulate around poorly maintained solar setups. Many electricians new to solar installations may find themselves unfamiliar with the crimped connections utilized in MC4 connectors. These connections differ significantly from the standard ones typically used in conventional electrical work. They resemble the crimps found in electronics assembly and require a specialized crimping tool. In fact, most MC4 connectors are pre-wired to solar modules directly from the factory, which explains the choice of a connector designed for factory assembly rather than considering the practical needs of electricians in the field. Before we delve deeper, let's examine an original MC4 connector closely. MC4 connectors feature a plastic housing that encases metal connector pins known as open barrel crimp connectors. The first step in the assembly process is to attach the solar cable to the crimp connectors. Begin by stripping approximately 7 millimeters of insulation from the solar cable. Since solar cables are double insulated, you should remove both layers of insulation to the same length. We will start by assembling a female or positive connector. Insert the open barrel crimp into the crimping tool. This tool features a special locator to hold the crimp in the correct position, while a securing bar acts as a backstop, ensuring the stripped cable is at the required length within the crimp. The crimping dies are specifically designed to fit conductors of 4, 6 or 10 square millimeters. In this example, we will use a 6 millimeter squared conductor. Begin by positioning the crimp into the 6 millimeter die and partially close the tool, ensuring that the wings of the crimp align properly with the die. Then insert the stripped wire into the crimp until it reaches the backstop bar. When you close the jaw of the crimping tool, it folds the tabs of the barrel crimp using the die as a guide. This action compresses the cable strands, creating a strong mechanical and electrical connection. After crimping, lift the backstop bar to remove the crimp. You should observe that the crimp connector securely captures all strands. Insert the crimp into the plastic housing. You don't need to remove the back nut. As the crimp connector enters the housing, you should hear it click into place. At this stage, the crimp cannot be removed from the housing. You can check the correct placement within the connector using a test pin. When correctly positioned, the white line will still be visible. To complete the assembly process, the back nut needs to be tightened around the cable. This adds additional strain relief and prevents moisture entering the connector. First, tighten the nut using the MC4 spanners and complete the process using a torque tool set to 3.4 Newton meters. If you're an occasional crimper, you might hesitate to invest in an expensive crimp tool just to attach a few solar connectors. Instead, you might consider using one of your existing crimpers or trying to bend over the crimp with regular pliers. When assembled correctly according to the manufacturer's instructions and using the right size cable along with a proper crimping tool and die, MC4 connectors provide a reliable connection system. Millions of these connectors are installed in solar installations worldwide, and it's easy to connect the two connectors together for fast assembly, but they require a tool to disconnect. MC4 connectors have a high current rating but aren't designed to be disconnected on load, and this symbol on the side serves as a reminder. confusion can arise regarding the connectors, which are classified as male and female. Typically, the female connector is marked with a positive symbol, while the male is marked as negative. However, upon examining the connector body, this labeling seems misleading, as the female connector resembles a male plug and the male a female. The orientation of the connectors is determined not by the connector shell, but by the pins, with the female pin fitting into what appears to be a male housing. The connectors shown here are commonly referred to as free connectors, which are attached to the cables of solar panels and the home run wiring from the inverter location. Additionally, you will find chassis mounted versions that are directly installed on solar inverters, as well as various combiner boxes and pre-assembled solar isolators. Why do MC4 connectors exist? Let's take a brief look at their history. During the first solar boom of the late 1990s, MC4 connectors triumphed over various competitors and became the standard for most solar panels. The MC stands for the original manufacturer multi-contact, while 4 refers to the diameter of the connector pin, which is 4 millimeters. Since 2002, multi-contact has been a member of the Staubli Electrical Connectors Group, under which its connectors have been marketed since 2017. These connectors offer a plug-and-play solution for various components of solar installations, and original Staubli MC4 connectors are factory-fitted to most solar panels. As of 2022, Staubli claimed a 50% share of the solar connector market. This presents us with another question. Who has the other 50%? As the solar PV market is constantly under price pressure to generate return on investment and save the world from global warming, manufacturers of solar panels and inverters are on the lookout for cheaper alternatives. So often panels or inverters are supplied with clones of the original MC4 connectors. Is this such a problem if the connectors fit together? At first glance, the performance of solar connectors may not seem problematic, as it is governed by IEC standard 62852 2014, amended in 2020. However, this standard does not specify exact connector dimensions or the type of crimp connector required. It merely states the exhaustive test that should be conducted on a family of connectors, which means that plugs and sockets from the same manufacturer must be used together. While some manufacturers assert that their connectors are compatible with Staubli MC4 or claim to have undergone independent testing with Staubli connectors, it is important to proceed cautiously. Staubli does not provide a compatibility chart or endorse any third-party connectors for use with their original products. A manufacturer may create a connector that passes tests when paired with a Staubli MC4 connector. Still, any changes Staubli makes to its manufacturing processes or materials could invalidate that independent testing. Therefore, it's crucial to acknowledge the risks involved. And I can demonstrate this with these two connectors. Although they appear similar, the depth pin used to check the correct crimp engagement supplied with the Staubli toolkit does not even fit the barrel of this equivalent connector. That's not to say this solar connector is not high quality. As a system of mating parts, it has passed the tests defined in IEC 62852. You will also find many well-known connector brands such as Phoenix Contact, Wiedmuller and Amphenol supplying solar connectors similar to MC4, which may indeed mate with one another. However, they are also accompanied by disclaimers within product data sheets that they should only be used as a system, and mating with other systems may not be covered by the product warranty. While trusted manufacturers have introduced innovative alternatives to the original MC4 connectors, including toolless versions, it's crucial to be cautious of counterfeit connectors that falsely claim to be original MC4 products. We purchased a selection from a well-known online retailer known for next-day free delivery. Many users find that the look and feel of these cloned versions fall short of the genuine connectors. A key indicator, as noted by Staubli, is the colour of the O-ring on the connector barrel. Original MC4 connectors always feature a black O-ring, while these clones typically have an orange one. The risks associated with cross-mating are further reinforced in various codes of practice for solar PV installation. Just to further drum that home, looking at our crimps within our MC4s that aren't actually MC4s, you can even feel the difference between them. So this one here slides like a trombone, where this one is actually seems to have some reasonable resistance. So what does that difference actually do to the contact resistance? And the other problem, what if I mix up these ones with these ones? Because they do look almost the same. Turning to RC62 recommendations for fire safety with PV panel installations, published by Risk Authority, section 5.7.4. Mixing of PV-DC connectors from different manufacturers should be avoided, and all panel connections should use the connectors recommended by the panel manufacturer. System operators should hold spare PV-DC connectors compatible with the PV installation for future maintenance to avoid the potential use of incorrect PV-DC connectors. Internationally documented PV fire loss data identifies faults with DC connectors and DC isolators as primary causes of fire. Therefore, it is essential to use the correct PV-DC connector assembled according to the manufacturer's guidelines with the correct length and thickness of exposed DC cable, the correct crimping tool for the connector pins, and the correct torquing of the connector cable glands. IEC 625-48-2016 and IEC 60364-7-712-2017 explicitly do not allow the connection of DC connectors from different manufacturers. For once, we're talking about solar here, and it's actually sunny. That last IEC standard, well, you might not be that familiar with it. You probably won't want to buy it because they're incredibly expensive. But if you're watching from the UK, it flows through into our trusted Brown Book and the wiring regulations. And if we just look at section 712.526, electrical connections, each pair of connectors shall be electrically and mechanically compatible and suitable for the environment. It's recommended to check with each manufacturer that each pair of connectors be compatible. That sounds like a lot of work. When faced with the need to mix connector manufacturers, there are typically three scenarios to consider. First, regarding solar panels, these panels come equipped with sufficiently long male and female cables to connect adjacent panels. So for most installations, the specific brand of the MC4 connector is not a significant concern. Generally, the electrician only needs to attach an MC4 connector at the first and last panels in a string, or connect a string around installation obstacles such as skylights. If you can't find a compatible brand of MC4 connector, the safest approach is to remove the factory fitted connector and replace it with a matching connector from your preferred brand. However, be cautious. Some manufacturers may void the warranty if the factory fitted connectors are removed. The next scenario is the solar inverter, which in many cases are pre-fitted with chassis mounted MC4 connectors. Most manufacturers will include the mating connector for the solar string cable with the inverter. On this SunSync inverter, they use Devlin connectors which look like MC4 connectors, but they use a different style of crimp connector for which we had to source a suitable crimping die. Finally, it is essential to verify compatibility with other factory assembled solar systems such as solar PV optimizers or micro inverters, which come equipped with connectors for integration with solar modules. It's important to note that the design of the original MC4 connector has evolved in response to advancements in solar installations, particularly regarding voltage. The original MC4 supports installations up to 1000 volts DC, while the newer Evo 2 version accommodates system voltages up to 1500 volts DC. However, a word of caution, the specific voltage and current ratings are governed by IEC and UL standards, which can vary. Therefore, depending on your region, ensure you adhere to the correct standards. Thankfully, the original MC4 and the Evo version are compatible. If a panel comes equipped with Evo 2 connectors, you can still use an original MC4 for the connection. Just be mindful of the design voltage. Previously, we discussed the crimping process and the necessity for specialized crimping tools. What if the MC4 connector has evolved again into a toolless version that eliminated the need for special equipment and allowed for quicker assembly on site? The good news is it has, and you can learn more about it in this video currently on screen.